Flora, thanks so much again for joining us today. And I will hand it over to you. We can see your screen, and today we're going to present addressing challenges in the urban-rural mobility continuum. So I'll hand it over to you, and thank you so much.
Great stuff. Thanks a million, and I'm delighted to join you all virtually today and to present some of the research interests that myself and my group are looking at the Technological University of the Shannon. So I'm based in the Limerick campus, and we've done some collaborations with Marcus, who you all probably know well, in this area of future mobility, intelligent transport. And I guess I should maybe try and explain a little bit what this perhaps convoluted title is talking about. I'm not sure how many people are in the area of future mobility or intelligent transport systems, but I'll explain what I mean by intelligent transport systems, just in case that some of you aren't in this area per se, and particularly why we're interested in the rural element of intelligent transport systems. And the first part of the title there concerns the urban to rural mobility continuum. Basically, what we see emerging is a very urban-centric, motorway-centric development of advanced autonomous transport, while a lot of the rural side of that road infrastructure has yet to be explored. So we're seeing a bit of a disconnect, not a bit actually, quite a bit of a disconnect between intelligent or future mobility possibilities at an urban level versus a rural level. So just in case some of you might be wondering what I mean by intelligent transport systems, you're all probably well familiar with autonomous vehicles in terms of onboard sensing, so LiDAR, cameras, infrared, on board the onboard vehicles, helping that vehicle to navigate somewhat independently. Now, regulation-wise and technically, there's still human control over the actions of autonomous vehicles, but the potential is there for that vehicle to utilize onboard sensing to effectively navigate various types of road conditions. But in addition to that, you have these vehicles that are connected, so they're communicating either to each other, so vehicle to vehicle, exchanging data, giving some updates to each other, and now we actually have the roadside sensing component of this. So you have sensors at the roadside edge communicating to the vehicles, so infrastructure to vehicle, and then obviously the other way as well, vehicle to infrastructure. And then the wider scope of this is actually, entire smart cities, or that's the future vision, entire smart cities communicating with the entire transport system. So you have this cooperative system for transport, where the vehicles are exchanging data and information with the roadside infrastructure and with surrounding buildings and other types of infrastructure as well. So that's the notion of intelligent transport systems, or the aspirations of intelligent transport systems, still very much in its infancy, right across from the technology to standards. Now, increasingly this is being referred to as cooperative intelligent transport systems, just to give recognition to that kind of two-way information traffic between the moving agent and the stationary transport agents. So I guess this brings on to, how is this kind of happening? So what's involved? So on the outset, you have to model or define the parameters in terms of how these vehicles will navigate the surrounds. Now, officially, these will be referred to as operational design domains. So you have city models, for example, and you would then have defined parameters. You would have other metadata such as weather conditions. There could be other types of dynamic data such as roadworks. All of these feed into the operational design domain that gives the reference point for the autonomous vehicle to pinpoint where it needs to go and what are the potential issues that it may encounter along that road. These are primarily or almost exclusively geared currently towards urban and motorway scenarios. And in Europe, this is bringing up an issue because the vast majority of road network in Europe, and Ireland is a great example, is rural secondary road and even rural primary road that's non-motorway. And the vast majority of road fatalities unfortunately occur on rural roads. So in Ireland, 2020, the road fatality ratio was 82% on rural roads and 18% in urban settings. As far as I recall, I'm not sure if even there was a fatality on a motorway, and there may have been, but I think that was factored in that statistic as well. And that would actually be fairly similar in many other European countries. There's some other European countries where there's a difference, or that gap is isn't so wide. But it's a good indication as to where the actual safety issue lies. Primarily is on the rural roads, and most of the focus hasn't been on rural roads when it comes to intelligent transport. Another issue that will crop up if this divide continues to expand between urban and rural is the mobility as a service element. So you can imagine if you had mobility as a service using autonomous vehicles as a service, transport service, that you have all of this facility and technology in an urban setting, and you need to go to another urban setting. In between there, you have this deficit in the technology and the service. So you have this sudden gap in terms of being able to utilize the full potential of autonomous mobility as a service. So there are lots of issues if the rural transport aspect isn't looked at. So just to illustrate a bit of context, so on the left here, you can see this is the M9. Has certain types of characteristics, and it has features that are that facilitate the likes of optical sensor systems and camera systems pretty well. You have significant line of sight, and you have quite a controlled setup in terms of traffic flow. So traffic is flowing in one direction. There's a very secure barrier between the opposing traffic flow. In the center, you have, this is an image of Cork City. And again, even though it's complex and there's a lot of work to be ironed out when it comes to urban autonomous driving, it does have a structure and does have other facilities that enable vision and optical sensor systems to function really well. Plus, of course, you have the network infrastructure and the roadside traffic control infrastructure in place as well. And then over to my right, you have the N20. which is, a very common road format in Ireland, and quite a common road format in Europe also. And you can see here that we're looking at a relatively straight stretch, but we're coming up to a corner and there's a lot of vegetation. There is no hard shoulder. There's potential here for danger and unpredictability. So this is actually heading in towards Buttervent, and if anybody has driven the N20 from Cork to Limerick, you'll know that section pretty well in terms of the amount of windy sections there and overgrown hedgerows. So the point here is that, the focus in terms of modeling and devising the operational design domains for autonomous driving have focused on the motorway format and the urban format. That will not translate really, that won't translate readily to the typical rural format. Now, bear in mind, the N20 is a primary route. It's not a secondary rural road, it's a primary rural road. That's, connecting two major cities in Ireland. Just to illustrate the complexity of that autonomous driving will come up against on rural roads. This is just from my own dash cam, where I live close to Kinsale. I hope this video plays. I'm sure you'll appreciate the complexity of navigating this as a autonomous vehicle. So I'm sure most of you have, some of you drive these types of roads every day going in and out of out to work. So we need a different approach when it comes to rural intelligent transport to enable autonomous driving. We need some other supplementary approaches that will lock into the existing advances that have been modeled for motorways and urban. But we also need some unique or dedicated methodologies when it comes to roadside sensing in particular. So the main issue that I like to highlight is really the issue of line of sight. Line of sight is regularly interrupted in these types of rural roads, and this degrades the potential of vision and optical systems. And what we're interested in at TUS is looking at an alternative sensor modality, and that's acoustic sensing. So our background is acoustics and audio signal processing, and we're looking at devising systems where we'll be able to gather the sound signatures of road users on the road, similar to other sensors, but we're using the sound signature instead, and that we'll be able to build a scene classification near real time of that road scene. So any kind of road events, accidents, that those will be detected acoustically and relayed then to neighboring vehicles for safety reasons, obviously, and obviously for traffic diversion if needed. So we orientate towards the notion of multimodal sensing, and then obviously sensor fusion, which is actually quite common in intelligent transport systems, where sensors, information from LiDAR, infrared, and camera are fused to give a better, more intelligible picture of urban and motorway road scenes. We envisage that acoustic sensing will also play a part in that sensor fusion protocol. So we work closely with the Future Mobility Campus Ireland, which is based in Shannon, and they run a test track facility there. So this is the private proving grounds that you see in the image. This is us just getting set up. We have reference microphones for acoustic measurement, and we also have for reference a binaural dummy head. We use this because we want to get some kind of reference point as to how approximately how a human would hear a passing vehicle. So we drive various vehicles, EVs, diesel, petrol vehicles around this track, particularly at the corners is what we're interested in. So we actually set up a microphone system to capture at the corners as the vehicles are rounding the corners. And we're currently building data sets as training data sets for machine learning models. So that's our current activity and the phase, fairly early phase yet in terms of where we're at in our research. And I guess this brings me to just briefly mention the notion of data spaces. So in mobility, future mobility, intelligent transport systems, there's a significant amount of data being produced. That's the actual signal data itself and the metadata and reference models. And all of those are, you know, there's a lot of research to see, okay, where does this get processed and stored? So you have across 3 different network layers, edge, fog, and cloud layers, where various aspects of or various modules of data are stored and processed. We're involved in a pilot project run by HANet and iCheck called IRL-DAT, and we're uploading our track data and the metadata, because we use weather stations as well, and data from the vehicles to upload all of that data to the IRL-DAT project. And this project is an open, or will be an open active data repository based on FAIR principles, and also has a very handy version control in there. So, you know, people can use the data that we're gathering in whatever manner that they want. And even if it is overwritten, we actually have still a traceability of our original files. That's how that system works, the IRL-DAT project. It'll become a national project after it's completed 2 phases of piloting. So it's currently in its first phase of piloting. And I'd also just like to very briefly mention about ITS standards. Standards is at the core of intelligent transport research. And it's probably at the core of a lot of your own research as well, but it's relatively new as a standard movement. But personally, I've found being involved in standardization to massive benefit in terms of involving standards from the very start of my research pipeline, so that I'm compatible with the emerging data formats, container formats, APIs, and the reference architectures. So I'm the head of delegation at NSAI for ISO and CEN standards in ITS, and I'm just letting you know that if anybody is interested in getting involved in that side of it, you'd be more than welcome to follow up with questions either after this or offline as well, if you'd like to get involved in standardization. Just to mention that some of you might have picked up the memo from the European Commission that there'll be more emphasis put on standardization, involvement standardization in research funding models. That was released in March. So it's, you know, it's an important aspect of certainly your research, and I would say that, you know, consider it at some point if you're not already involved in standards yourselves. Okay, so I'm just wondering at this point if I hope I'm on time. And if there are any questions, anybody want to, even if you want to ask more about IRL-DAT, not specifically about our own roadside acoustics research or about standards, NSAI, ISO, or SEN, please feel free.
Thanks, Laurie, very much. That was very informative presentation, so thank you. And yeah, we'll open the floor here and anyone online for questions or comments.
I have maybe two questions initially. So kind of the first is probably, because I don't know, just a question around how far are we actually really away from autonomous driving in rural areas? So kind of a timeline. I really don't have any, like I know that the pilots and all this, but for the rural areas, so from the timeline. And the second one, that's more around the data spaces and kind of are there big European open initiatives where actually data spaces or open data sets are available where we could use it, for example, for research?
Yeah, so I might start with the second question first. That's okay. There are data spaces like like EUDAT, for example, is like we're contributing our data essentially to that system, so it'll become federated. But there is a project that is I'll just get the name of it. Well, I'm actually trying to get the specific. Oh yeah, it says Prep D space for mobility. I'll put that in the link there. Again, it's this is what I would recommend as a kind of definitely the first reference point if you're interested in the mobility data space area. This would, in my opinion, be the kind of leading European project to follow. Like much of from an acoustics perspective, much of the data space relies on pulling from the likes of YouTube videos, which is great for analyzing crash data, but beyond that, it's very non-specific. So for us, a lot of the existing data sets in acoustic scene classification, for example, is not much use because we want very specific tire on road signatures that are cornering around the road. So we're looking for a very particular type of without falling foul to overfit in our machine learning aspirations, but we want very particular types of data, acoustic data. So we have to build our own essentially for our specific project. But in terms of the wider data space mobility, that would be the first protocol there. Did everybody get that in the chat?
Yeah,
no?
Thanks. Yeah.
The first question, I think I generally don't want to put a timeline on it because a lot of the timelines that have been put on advances in autonomous driving have failed miserably.
No, we only record these sessions, it's 2023 now, and now like. Okay, so if I'm invited back in 2053, we might have a different update, perhaps. But no, I'm only joking there. But the rural hasn't gotten much attention at all, so I don't think it's going to be a feature anytime soon. The major pilots have been focused in on motorways, the primary road arteries in Europe and urban, and I think it'll continue to be that for a while because there's still a lot of issues to be surmounted. I think Europe is more unique in terms of the issues that it faces in terms of autonomous driving compared to North America and Asia. When I say Asia, I'm particularly probably focused on the road infrastructure that has been recently
relatively recently built in China, where you have a much more probably organized road format, whereas in Europe we've inherited very old road formats that were never envisaged for vehicles in the first instance. So it brings up extra complications, but it's certainly one that that is starting to get attention at the likes of transport research arena. So rural is starting to be mentioned as an area that needs to be focused on. I'd say it probably doesn't have that focus just yet.
No, and I can just imagine, like on a motorway, it's probably doable because of the layout, and it's kind of also more conform the traffic flow. But when I think about the rural area, like you had that one video just about the layout of the road, but I can also imagine there are different, like when I think about the tractors, the agricultural traffic, and all of this. So they're quite diverse, different kind of traffic situations in rural areas.
Yeah, very much, and also affected by seasonal changes a lot more. So vegetation growth is a lot more impactful on rural roads than on motorways. So you have it's a lot more complicated and it's a lot more varied. So I suppose like it does make sense to start with motorways and city models, because it's more controlled. It's easier to iron out the issues at that level. So it's probably a natural evolution that rural comes later, but there's certain things that can happen where it can fast track the rural dimension of this. Personally, I don't think that like when people talk about barriers to intelligent transport for rural, they immediately think of network issues. I don't think the network is going to be the bottleneck for rural intelligent transport. It's going to be sensor compatibility, the complexity in modeling, that infrastructure to be a proper reference architecture for the system. I think there's enough work done, or there's a good trajectory in terms of networking, that networks won't be an issue. So the communications, I don't think is an issue. I think it's just on the ground sensors, on the ground sensing compatibility, that kind of stuff is the roadblock.
Yeah, just the final comment from my side, and then I hand over to Carol. First of all, thanks for the informative presentation, but I also like, because we record this session, so if you play it in 2033, I might still like driving, like not autonomous. So I really like to drive on this. So that's probably also a factor to consider, that actually the driver by themselves, so maybe it's not all autonomous, and then to integrate the autonomous and the traditional driving into these rural roads areas, that's probably really challenging. So yeah, so that's just a comment for the record, when we have that all recorded, that in 10 years I probably still like to drive as well. So thanks, Carol, and over to you.
Very good. Yeah, and thanks again for, unfortunately, I think we're going to have to leave it there for today.
Yeah.
But thank you for also, reaching out to say people could contact you or us here at IVI with any more questions. So anyone, obviously, feel free to. And hope you can join us next week before we continue our coffee talks, and just some details there on to get in touch with us, or to sign up for our newsletter, and our social media details on Twitter and LinkedIn there. So thank you all very much for joining. And Florrie, thank you again for the excellent presentation.